Okay, is it visible? If someone can just confirm. Uh, can someone please confirm if the screen is
Yeah, it
visible?
is visible, Pooja.
Oh, thank you. So, yeah, so today we will be looking at descriptive statistics. And first we will go through the basics, the mean, median, mode, the usual ones. And then we will look at how this paper, which is titled Sleep Quality, Sleep Propensity, and Academic Performance, how they have used descriptive statistics in their paper. So, in a way, we will get the basic understanding of what descriptive statistics is and why do we do descriptive statistics, and then we will look at how they report it in research papers. So, okay. All right. So first, why do we even need descriptive statistics? So when you deal with data, suppose if you're looking at data in R, here they have looked at this data, which looks at the margins of some, I think, football team, and if you just look at this data, you are just looking at numbers. You are not really understanding what is going on here. To really understand, to get insights, to look at what kind of scores or what kind of numbers we frequently see or what is the average, for this purpose, or to get like a basic gist of the data or the summary, we then use descriptive statistics. So descriptive statistics includes many different things. You can look at the average, you can look at the mode, you can look at the range, the spread of the data, and we will discuss all of these things in a minute. So basically, descriptive statistics helps you understand the data. It helps you get the uh, a gist of the data. Like, you know how the abstract gives you a gist of the paper. In the same way, descriptive statistics give you like what is the average of the data, what is the range spread of the data. And there are many different ways to do it. You can do it with mean, median, mode, or you can use some visualizations, like people look at histograms, people also look at box plots. We will also discuss that in a minute. So coming to the main descriptive statistics that you will see everywhere in the research papers, the main ones that are usually reported is mean, median, and mode. And so, what are mean, median, and mode? These are basically measures of central tendency. It gives you an idea of, you know, what kind of score is representative of your overall data. When we talk about mean, there is the inference that it is kind of the average and representative of other scores. And when we talk about median, median is usually the middle point of the data. Okay, so when you are looking at this two graphs here, if you want to look at the difference between mean and median, you can consider mean as a balancing point. So here, this is the balancing point. But if you're talking about the median, median is the middle of the data. So this here, this would be like sort of the middle. So uh, half of the scores are on top of the median and half of the scores are below the median. Whereas mean, it takes it takes all of the points in consideration, and it takes the average of all of the points. If say you have looked at the uh, usual formula for the mean, where you just add all the data points and then divide it by the number of observations. So I didn't really put the formula here because we have seen the formula, and formulas are not very pretty to look at, and it usually uh, people get also intimidated when looking at different formulas. So just to get a more intuitive understanding of mean and median, I have put these graphs. So if you consider this a seesaw, mean would be here. It would balance the data on all. It is taking into consideration all of these data points. Median would be here. Median, on top of the median, like the above half is the, like above the median you will have 50% of the data, and below the median you will have lower 50% of the data. And when we talk about mode is simply the score that you get most frequently in your data. So if, say, here we are looking at winning margins. So here the histogram, this bar, it presents this winning margin from, say, 0 to, say, this point. It is most frequently being observed in the data, so this has the highest frequency. So this margin range, we can consider it to be the mode. So mode is simply the most frequent score that you observe in the data. So if you are, say, looking at the scores that a class has got in an exam, you can look at what kind of score is most frequent. So you'll understand where the class stands and what kind of scores most people are getting. Or you can look at the mean, where you understand what is the average kind of score the class is getting. But mean gets problematic when you have outliers in your data. So let's say you have in your data you have like 5 scores, 1, 2, 3, 4, 5, but there is one score which is like 10. So if you calculate the mean, you will get somewhere, you will get your score, the mean to be somewhere between, say, about 3. Because if you just take the mean of 1, 2, 3, 4, 5, 3 would be the mean. But if you take a score, if you add a data point of 10, your mean would increase. But it's not necessarily representative of the data, because there is just one outlier. And that outlier will be inflating your entire mean score. So which is why when we have outliers in data, I'm so sorry, that was my earphone. I don't know if everyone could hear that. So yeah, so when we have outliers in the data, and when your distribution is skewed, like this is a skewed distribution, when it's not like a proper normal distribution, mean cannot be trusted. And that is when people usually go for this another method, which is the trimmed mean. Trimmed mean is when you get rid of outliers on both sides of the data. So if you have, say, 10 on one side, you get rid of that, and then you get rid of the other side of the data as well, 1. So what you get is the middle, the remaining rest of the part, which does not have the outliers. So we will, in the next session when we do this, I will show how to do all of this in R. But right now we are just trying to understand what it means theoretically, and then look at paper. And next session we will also look at how to do these things in R. So trimmed mean is used when we have a lot of outliers, or when the data is not normally distributed, and then basically we just remove the outliers in trimmed mean and then take the mean. And also another way you can do is you can look at the median score, because median is not sensitive to the outliers. It is the middle point of the data. So in these two histograms, if you see this, this here, it is closer to the body of the data. A lot of scores are falling in this range. So your median is here, but mean is towards the tail of the data. So this is called the tail of the data. And there are not many observations towards this tail. However, because there are these outliers, your mean is being shifted towards the right. But if you look at the median, it stays closer to where the middle point is. It is the middle point, and it is not affected by these extreme scores. These on the right hand side, these are the extreme scores, because there are not many data points here. These individual squares that you see, they represent each data point. So on the extreme side, you don't have many data points, but these scores are like really huge compared to what others are scoring. So if you see, median is not being affected by these extreme scores, but mean is being affected by it, which is why when we have such extreme scores, you can also go for median. And whether you choose mean or median also depends on the type of data you have. Whether when you have usually ordinal kind of data, median is preferred. But when you have say interval or ratio kind of data, mean is preferred. And we can also look at why exactly we do this, but right now let's not dive into that because we also have the paper to discuss. So right now you just need to understand that mean is the center of mass, or like the balancing point, or median is the middle point of the data. And median does not get affected by the outliers, but mean does. And when you have outliers, you can go for the trimmed mean and also look at the median. Now coming to measures of variability, what does it mean when you say that there is a lot of variance in your data? So variance, it means that your data points are differing from each other a lot. If you want to see this visually, here it is there on the next slide. So if you look at this right hand side, this graph, these data points are like really spread out. So when we say that here the SD is 31.6, this SD actually represents how spread out this data is. But if you look at this data, here the SD is 7.9. Here the scores are not that spread out. They are closer together and there is not much variance in the scores. So measures of variability, it shows actually how different each score is in the data, and the reference point is the mean. So how, when you look at say the standard deviation is the most common measure you see reported in the papers. So standard deviation gives you how each score differs on average from the mean. And range, you all know, range is simply the highest value minus the lowest value in the data point. So it just gives you like a proper value of how much the data is varying. And standard deviation is like an average, you can say, of distance from the mean. And variance also gives you a measure of how much the scores vary. But if you have looked at the formula, it is actually squared of all deviations from the mean. So because there is a squaring, the units of variance is not the same as the original units. So basically, if you were looking at height, your height is measured in meters. If your original unit is meters, the variance would be expressed. uh, am I still audible? Can someone just confirm?
Yes, Pooja, you're audible.
Okay, I'm so sorry. My earphone keeps getting connected and disconnected. So, yeah. All right, so variance, the units are squared, which is why the interpretation becomes a bit tricky because if you see the formula there, they have squared the deviations from the mean. But standard deviation is preferred because it has the same units, and because we take the root of all of those squared deviations from mean, it comes down to the same unit as the original value. So which is why standard deviation is usually preferred. And interquartile range is so interquartile range, it's less frequently reported compared to ST, but interquartile range is basically the difference between your 75th percentile and the 25th percentile. So basically it gives you the range of middle half of the data. So if you have a lot of outliers, that is when interquartile range is more robust because it is not being affected by extreme values. So that is when you will see interquartile range being reported. Also, when you report median, usually you will see interquartile range being reported with median. So we will look at how it's reported in the papers. This I have already explained. This is how the data varies. A large ST shows that the data is very spread out. A smaller ST shows the data is not that spread out. The scores don't differ that much from the mean score. And another way people descriptive statistics is by looking at different plots. You have already seen what histogram looks like. This is a box plot. So box plot shows you where the median lies. So these are the medians. For this graph shows the days from ICU admission and the pallet count. Basically, on each day from ICU admission, how the pallet count varies. So between the first and second day, you can see the median pallet count was, say, 200. So the line in the box plot gives you the median, and the this box, these ends of the box are the 75th and the 25th quantiles, and these whiskers are basically the minimum and the maximum values. So between first and second day, the pallet count varies from, it starts from 100, which is the lowest value, and it went up to maximum of 500. And between this, the median was 200, and this whole box is basically the interquartile range. So this is the upper 75th and this is the lower 25th quartile. So looking at this box plot, you immediately get to know highest, lowest points and median along with the quartile range. So we will just quickly look at this paper and how they have reported descriptive statistics. So this is a comparatively older paper, which is why they have not used many plots. In this paper, they have just reported mean, median, means, I think, means and SD they have reported. So in this paper, they are looking at how sleep quality, sleep propensity, it is related to academic performance. So I'll just quickly read this out. We examined the association between measures of sleep propensity on Epworth Sleepiness Scale, sleep quality on Pittsburgh Sleep Quality Index, and academic performance by GPA and grades in introductory psychology for 414 students. So they found that neither sleep propensity nor sleep quality correlated with GPA or introductory psychology grades. However, when students were carrying a full course load, they reported those reporting poor quality sleep performed less well on academic measures than those reporting a better quality sleep. So sleep quality only mattered when the course load was heavy. If the student wasn't carrying a heavy course load, that time sleep quality wasn't correlated to GPA. But they say that further research is needed to assess the moderating influence of overall demands of daytime functioning on association between sleep quality and academic performance. So yeah, so this is just their basic participants data. So here they have total 404 students from this university. They report the total number of men and women, and they say 9 participants haven't specified their sex. Ages range from 17 to 50. So see here they have mentioned the lowest is 17 and highest is 50. And if you wanted range, you could subtract 17 from 50. So that would be the range for ages. And they have reported the mean value for age, which is 20.1, and they have given SD, that is 3.8, which means on average, that is how much the age is differed. So 3.8. It is a relatively average, like usually you see such SDs. And across the sample, 246 students, including 77 men and 162 women, carried a full course load defined as 5 or more courses during the current academic time. So if you remember in the abstract, they mentioned only for students carrying the entire course load, their sleep quality was associated with their GPA. So for these students, 77 men and 162 women carried a full course load. So looking at their data, they found an association. Okay, so this is just sample characteristics. And here, this is the result section where they actually give the descriptive table for all of their scales. So if you are including any scales in your study, usually you will mention the means and SDs and total number of observations on those scales. So here, all of these scales, the sleepiness scale, Pittsburgh sleep scale quality index, GPA, introductory psychology grade, they, for all of them, they have mentioned their mean and their SD for men and women. And they have also looked at correlation between these scales. We can discuss correlation later when we are on that topic. Let's just right now concentrate on this. So let's compare within these values. If you look at this SD for sleepiness scale and the SD for GPA, so if you try to imagine how the distribution would look, for GPA, more scores would be closer together around the mean because the SD is less. If you look at the data for sleepiness scale, the data would be more spread out around the mean because this value is higher. So in that way, you can kind of compare where the scores are varying more compared to others. And yeah, here they have just given the same details. And because we are right now not focusing on any of the inferential statistics, let's not discuss this p-value. We will discuss it later. So yeah, even here they have mentioned different means and STs. Uh, so this one, descriptive sleep statistics obtained from open-ended questions on gave a mean bedtime of 11:39 p.m., ST of 68 minutes, a mean sleep latency of 25 minutes, and ST 23 minutes. So here you will usually see means and SDs being reported this way. And because so this is all this paper reported, if you see newer papers, they also include a lot of graphs. So in this paper there weren't really many graphs, they just reported this simple table. So we don't really have other things to discuss here, but in case you have any doubts in regarding this table, please let me know so we can discuss that. So this, I have put the screenshot just to show how it is usually reported. When if you have suppose median or interquartile range, you can also report that. Median is usually reported as like MDN, or an interquartile range is specified within the brackets. You can, if the paper is mentioning median instead of mean, they will usually mention it ki it is the median value and not the mean value. So yes, this is it for now because this is all the descriptive statistics paper had. In case you have any doubt regarding this, please let me know. So this is all there is for descriptive statistics for now.
Pooja, uh,
Next, in yeah.
there's a question by Titli saying, can you explain the interquartile range from the data?
Okay. So which data are you talking about? This?
I'm waiting
So
for Titli's response. She said yes.
yes, so interquartile range. So it is basically in you look at interquartile range when you have like extreme values in your data, and it is a more robust measure because it looks at the middle half of the data. So from 25th percentile to the 75th percentile, it's the middle half of your data. Other 50% is below the 25th percentile and above the 75th percentile. So your extreme values won't affect the interquartile range. So your interquartile range would give you a better understanding of where most of your data lies. So which is why we look at interquartile range. And in this graph, you can see that in this box plot, this so this rectangle, sorry, this rectangle, the lower edge, this one, if you can see my cursor, this is the 25th percentile on the top, this is the 75th percentile, and this entire thing would be the interquartile range. If you want to look at the in the papers, you would usually just mention the like upper 300 to this is somewhere 150. So this is the interquartile range represented by the rectangle in box plot. This line that you see in the middle, this is the median value, and this because and the median value is also the 50th percentile. And these are called whiskers, which you see, this tail is the maximum value, and this is the lower minimum value. So if you wanted to take the range of entire pallet count between first and second day, you could just subtract this upper value. It is somewhere between 400 and 500. So take 480 somewhere and subtract it, and subtract about 100 from it. This is the entire range. This is the interquartile range. This is the 75th percentile. This is the 25th percentile. And this range is not being affected by this extreme values. So, yeah. Do you want any further clarification? I think you would better understand if you look at how it is reported in the paper and what kind of data they have used. I'm sorry, the paper that I have put here, they have only reported the mean and they didn't really look at any interquartile ranges. But we can later discuss papers which have such box plot means, medians, and interquartile ranges. And I can also show next time when we have presentation, I'll just quickly show how to do it in R. It's very easy. Basically, to get interquartile range, you just have to type IQR, and in the bracket just mention your data. So it's R makes it very easy to get all of these values. Let me know if you need any further clarification.
No, I understood it. Thank you.
No worries, I'm glad. Okay, so this was it for today. And I know we have not discussed a lot of things here, correlation, p-value, because we are saving it for future topics when we actually have that goal. So we will be discussing in the next presentation. If anyone has any doubt here, please let me know. Okay, in case no one has a doubt,
Uh, Subhasika has a question, and she asked if she
yeah.
can unmute and speak.
Yeah,
Subhasika,
please.
please do.
So in this slide, does the standard deviation imply that the entire data set lies between those two extremes? For example, if in this case, the Epworth sleepiness scale, the standard deviation is 3.77. So if we are to like 9 minus 3.77 is like 5.23, and 9 plus 3.77 is 12.77. So, would we be correct in assuming that the data set lies between 5.23 and 12.77?
Okay, so you asked a very good question of, I think you must have read that most of the data lies between, say, a specific SD value.
Yes.
So usually within one SD, I'm so sorry, I have not included that graph. So usually within one SD of your data, that is like you said, plus 3.77 or minus 3.77, you would get about say 68% of your data. I'm not sure if the value is right. If Munna, can you just look it up if it's 68? So most so that amount of your data would lie between that value minus 377 and plus 377. Then but a majority of your data, say 99% of your data, would fall between 3 SD and plus 3 SD and minus 3 SD. So, and this is for the normal curve. If your data is normally distributed, within plus 3 SD and minus 3 SD, 99% of your data points fall. But majority, like 68% of most frequent scores would be in 1 SD and minus 1 SD. So I got the graph you were talking about. Let me just see if I could quickly look at that graph on Google and share the screen. Wait, you can't see my screen right now, right?
No, we can't.
Okay, wait, I'm just sharing. I found one on Google. Okay, can you see this?
Yes, yes.
Yeah, so this is the mean value. What you were talking about 1 SD and plus 377 minus 377, it's this. So 68% of your data would fall between 1 SD and minus 1 SD, but 99% of your data would fall between plus 3 SD and minus 3 SD. So your question was if it is right to assume that most of your data would fall between this score. So the most frequent values you see, it would fall here, 68, 1 SD and minus 1 SD. So yes, 68% of your data would fall between this. So, and because these are the most frequent scores, it will fall here. And the more extreme scores would fall here. And you can catch those in plus 3 SD and minus 3 SD. So the more typical kind of scores that you get, you will get it within 1 SD and minus 1 SD. So your question of whether you can assume that plus or minus 377, 3.77, I think. So yeah,
All right. Thank you so much for clarifying.
you're welcome. That was a good question. I like that. Yeah. If anyone has any other questions. In case there are no questions, then maybe we could just stop. Or do you all want to discuss this data further? Do you have anything else in mind if you wanted to run any other statistics on this? Yes, please, Devanshi.
Good evening, ma'am. First of all, thank you for your effort.
Don't call me ma'am.
No, like for our beginners, I'm sure there must be like many beginners like me. It's a really a shrine where like statistics इतना easily से पढ़ना इतने simple concepts में. So I was asking if you could suggest any YouTube channel, credible YouTube channel where I can study statistics and R for starters. And like I
Right.
prefer audiovisual media more than reading.
Right, I get that. So, which is why I'm not sure if you have checked out the resource sheet. In resource sheet, we have color coded those cells. So, whichever green cells you'll find, you will find really good YouTube videos explaining those particular statistics. So, and the resource sheet you will find in the club's drive. And on from the top of my head right now, I can recollect this channels. It's there is Statistics Globe, there's Patrick's channel, there is uh, if you just look up and depending on what statistics you want to look at, different channels have like different areas of specialization. So some channels are really good with plots and explaining different kinds of plots. Some focus more on like more calculated kind of examples, like showing how to calculate different things. But you will find really good channels in the resource sheet, and the YouTube videos are highlighted with green color. So yeah,
Okay, ma'am, I will check them out. Sure.
just call me Pooja, it's okay. Okay, so is there, do you all think if you were writing this paper along with what they have mentioned here, do you all think you would have went about it another way or mentioned any other details which would help with understanding the data better? Yeah. Median, okay, right. So actually, further in this paper, they did mention a median value, but it was not exactly for the purpose of just giving descriptive statistics. They mentioned median value because they were using this technique called median split, which is why they had mentioned that. But it was, and a median split is also not a trusted technique. So yeah, that was further discussed in the paper, but not really from like giving a descriptive statistics point of view. So yeah, and right, median, it would be mentioned more typically when papers have, you know, such, say, ordinal. Median is usually preferred with ordinal measures because we had scales. Scales are typically looked at like interval and ratio measures. So which is why they went with mean scores. If you had like ordinal scores, they could have like mentioned median value. And one doubt I came across when I was reading the paper was they have looked at GPA. So, GPA, I was really wondering whether it's like they looked at it as a ordinal measure, as a ratio measure, or interval. But because they have given the mean for it, it looks like they have considered it a ratio measure. They mentioned they are the GPA, their ranges starts from 0. So which is why they gave the mean for it. Otherwise, if you look at just grades and turn it into scores, it could also be looked at like sort of like ordinal measures. So that really confused me whether they are looking at it like as a ordinal or if a ratio measure. Trimmed mean with, yeah, okay, Suasika, I'll explain that. And Devanshi, what question do you have?
Ma'am, can you please, like, in some another meeting, can you show like examples of levels of measurement, like all four scales?
Yeah,
Ma'am,
right,
like,
right, yeah,
we have studied the scales, but examples are only given out of like statistics, but not shown in how they are, like how we can identify actually whether a like particular item is based on ordinal scale, nominal scale, or ratio scale, like how they're actually used and like
yeah,
done.
right, yeah. We should definitely discuss that. And sure, we can have a session where we look at how to identify whether it will be interval ratio or different levels of measure. So yes, we can definitely do that. And there is one more slot in descriptive statistics, so maybe we could discuss that there. And yeah, I can definitely give some more examples. And so Asika, you had asked me to explain, wait, what was it again? Trimmed mean, right? Okay, so trimmed mean, say, let's say, to make it easier, I'm just writing it in the chat box itself. Let's say your data looks something like this. One, let's say minus, I'm just writing down things here in the chat box. Okay, so let's say your scores look something like this. Now 15 is greater, is much larger than these values. Say 5, 6, 7, 8. They are like just one, there is a difference of just 1 point between these. But if you look at 1 and 15, they are outliers here. I mean, not that major ones, but this is just for the sake of understanding. So your mean would be affected by this 15. So what trimmed mean does is it gets rid of the extreme values. So it would get rid of this 15 as well as this one and take the mean of just 5, 6, 7, 8. So your trimmed mean would get you a mean of just these central values. And depending on uh, how many outliers you have and where they range, you can choose how many values you want to remove, and like basically what percentage of data you want to remove. So when reporting, it is reported as like say 10%, wait, tre- uh, 10% trimmed mean. So what this does is it gets rid of, on the extreme ends, it gets rid of those single scores. So this is not exactly 10%. So depending on what percentage of data you want to remove, basically your outliers should fall in that range. So if your data lies in the say 95th percentile, so if you remove the top 10% of your data, it that extreme score would be removed. So yeah, basically if you want to understand in simple terms, if you for this data set 1, 5, 6, 7, 8, and 15, if for these value you want to look at trimmed mean, you would get rid of 15 and you would get rid of 1, and then you take the average of these middle scores. So that's how it's usually done. And I think you will find also different ways to do this. There is maybe, I think there is also way to just remove one sided, I'm not sure, but usually both, on both sides the scores get removed. So which is why your mean is based on this central data. uh, who had asked that question? Suvasika, right? Do you need further clarification on anything? Okay, no worries. All right. So if no one has anything else they want to discuss, then this is all for now. Uh, if anyone wants to discuss anything else, you can just unmute and speak. Munna, Ritik, do you want to discuss anything else regarding this? Or if you want to clarify any topic further, you can do that. Uh, We couldn't hear that. I'm not sure.
Hey Pooja, can you hear me?
Yeah, I can hear you, but I think Ritik was trying to speak. I couldn't hear that.
I couldn't hear him either. So the thing is, this is not really regarding descriptive statistics, but regarding what Devanshi asked about the resources. So like Pooja mentioned, we have put up green color marking for YouTube videos, and others. We also have like resources that are like on text or some things that, I mean, for people who like reading and learning stuff, they can use that kind of resources, and people who learn through visual representation, they can learn through YouTube resources. So that's why we have made a very wholesome curated list for you, all of you. So we would really appreciate if you can go to the resource sheet today or like anytime soon and go through the list and figure out, like, see which resource would work for you better, so that whatever which Pooja has mentioned today, you will be able to get a better understanding about it, and it will be kind of a revision sort of thing. And also, if you have any more explanation that is needed, you can check out the resources. Maybe that will give you more insights. So this is just like a baseline understanding about descriptive strategy. Again, there is more to learn, and like Pooja mentioned, there are more stuff that are coming up, and some topics will overlap with other topics. That's why even Pooja has ignored a couple of topics, and so we will deal with that in the upcoming sessions through presentations. And we really appreciate for you all joining once again. And yeah, Pooja.
Yeah, thank you everyone so much for joining. And 10 p.m. is not the best time, but yeah, we had to do it because people are here from all time zones. And unfortunately, the presenter couldn't make it because of the extreme weather conditions there. And I really appreciate all of you joining and asking the questions and discussing it. It really contributes to, better learning, because this will be recorded and many others are going to watch, and if they have the same doubts, it will help them clarify that too. Also, I wanted to point out that I'm not an expert here. I am just, so in case you find that something was incorrect, if when you are further exploring the resources, if you think something was incorrect, do let me know so we can like rectify that, and we can just leave notes regarding if there was a mistake on explaining certain things. So yeah, that's all I wanted to say. So yes, thank you so much for joining, and thanks to Irisha for taking the efforts and recording this. I'm really grateful for that. And yeah, so this is all for today. Okay, everyone.